All right, so this is help session number 2 over chapter 5. I'll go over this version here. Okay, so f of x equals negative natural log of x over x. Find each relative max, relative min. We're going to find the first derivative, and we're going to treat this like numerator and denominator, so quotient rule. Okay, so negative natural log of x, derivative is negative 1 over x times the g function, back to f, g prime, all over g squared. Negative 1 over x times x is negative 1 plus natural log of x over x squared. Okay. To find critical points, we set the numerator and denominator equal to 0. Natural log of x equals 1. To get that x by itself, we can involve the inverse to get rid of natural log. So the inverse is e. We can raise both sides, base e. X equals e. X squared, so x equals 0. Now there is a domain for our function, natural log of x. X can't be a negative, right? Natural log, we know natural log of x, that graph is not going to exist to the left of 0. It's only going to be in the positive region. So we know our sine line is only going to be to the right of 0. Okay, we choose values on either side of e. I can choose 1. Here you can choose a value greater than 2, but I always like to take advantage of e to make it easier for me to plug in. So I'm going to choose e squared. Okay, we're going to plug into the derivative and see what signs we get, whether positive or negative. Positive derivative would mean positive slope. Negative derivative would mean negative slope. So 1 in for x. Natural log of 1 is going to be 0. 0 minus 1 is negative. Negative over a positive is negative. So this interval, my graph is decreasing. E squared, plug e squared in for x. I get negative 1 plus natural log of e squared over e squared to the second. Bring the 2 down. 2 natural log of e, that's just going to be 2. Natural log of e goes away. 2 minus 1 is 1. Positive over positive is positive. Right, so we know we know interval decreasing, we know interval increasing, we know there's a relative minimum. So if I want to find relative minimum, I can plug e back into the original equation to get my order pair. Natural log of e is 1, negative 1 over e, that's my y value. Okay, so relative minimum, because f prime changes from negative to positive. Decreasing from 0 to e because f prime is less than 0. F of x is increasing from e to infinity because f prime is greater than 0. Good, Jake?
I'm good.
All right.
Why would it be increasing e to infinity? That's where like
Because
like
positive
that.
slope,
Okay.
right?
Yeah.
We don't care about the 1 in e squared anymore because that's just to test the intervals. But we know based on the arrows, right, how the graph is moving. Okay. Number 2. Position function. This is a particle moving along the x-axis. We have e to the t times t squared minus 3. Find the velocity. I need to find the derivative. To find the derivative, hopefully we see that there's a need for product rule, right? These are two separate terms, separated by multiplication. F prime g plus f g prime. Okay, e to the t becomes just e to the t times 1. Back to f, g prime. Just going to do a little bit of cleanup. We don't have to, but it just makes it a little cleaner. I can factor e to the t out. Good. Okay, so now to find the acceleration, I can also think of these as two separate terms. Product rule again, f prime g plus f g prime to get from velocity to acceleration. F prime, e to the t becomes e to the t times 1. G function. Back to f. G prime. Factor e to the t out. Okay, for part C, for what values of t is the particle moving to the left, we have to create a velocity sine line. So first, we want to set v of t equal to 0. We know e to the t is not going to produce anything because e to the t is the exponential function that hovers above 0. So there's no solutions there. We're just going to set that t squared plus 2t minus 3 equal to 0. We can factor. Solve for t, we get -3 and 1. Velocity sine line. Test intervals here. Choose values on either side here. Plug -4 in into the velocity function. You know that e to the t is always going to be positive. So -4 plus 3, that's negative. -4 minus 1 is negative. Negative times negative is negative. Sorry, negative times negative is positive. 0. 0 plus 3 is positive. 0 minus 1 is negative. Only 1 negative. 2 plus 3 is positive. 2 minus 1 is positive. Okay, moving left. Moving left is when velocity is negative. So moving left from -3 to 1. Because velocity is less than 0. Okay, part D, is the speed of the particle increasing or decreasing? Speed increase, decrease, that means we have to look at both velocity and acceleration. So we know that v of 0 is negative. So now we need to find a of 0. Okay. So insert back into the acceleration function. Positive times negative is negative, so acceleration is also negative. Since velocity and acceleration have the same signs, speed is increasing. Good, Jake? Okay. Okay, number 3. This is a problem that we can think of, treat it the same way that we would if you saw natural log of a times b, right? Think of that as your a, think of that as your b. Instead of log base e, this is log base 10. So there's a hidden 10 here. The way you would expand this, you would say natural log of a plus natural log of b. So same process here. We're going to treat the x as the a, treat the cube root as the b, and expand. So log of a, which is x, log of b, which is cube root of the parentheses. I'm going to pull that parentheses out as parentheses to the 1/3. and then continue expanding. Bring the 1/3 down in front. No derivative yet. All we're doing is just trying to make our life easier when we're ready for our derivative so that we can find the derivative. Okay, so the derivative for natural log is u prime over u. Now this is not base e, this is base 10, so the derivative is going to be a little bit more than this, but it's going to be similar. There's going to be a conversion that's going to be in front, so 1 over natural log of a, which is just a number. But then the rest of it looks like the natural log rule, right? Still have that u prime over u, just need that little bit of a conversion out in front. So here, we know it's going to be 1 over x, u prime over u, but then in front, this log base 10 is going to have a little conversion that's going on, so 1 over natural log of 10. Here, 1/3 is going to stay coefficient. This is still u prime over u, so 1 over 20x cubed over x minus 5x to the 4th, but then the log base 10 has its thing going on here, so 1 over natural log of 10. This step is fine. I just decided that I want to merge this into 2 separate fractions instead of all this messiness, so I clean it up a little bit more, but either is fine. Good. Okay. Okay, number 4. A couple of things going on here. There's natural log of x over y, which is expandable. We have to expand. And then there's implicit going on, because you see y is all over the place. And then there's a hidden product rule here. F prime g plus f g prime, x and y are being multiplied. So a couple things to note. We have log expansion. We have implicit differentiation. And we also have product rule for derivatives. Okay, so first thing we can do is we can expand, take that natural log of x over y, expand it into natural log of x minus natural log of y. So I'm rewriting the rest of the equation because I'm not ready for the derivative just yet. Okay, so now we're ready for our derivative. Each term, we can just apply whatever rule is necessary. Anything involving y, we have to attach dy dx. And there's also product rule going on here. So natural log of x becomes 1 over x. Natural log of y becomes 1 over y. We just asked for y's derivative, so we need dy dx. And then here's product rule. X is your f function. Y is your g function. So then here, f prime times g plus f g prime. X becomes 1. We keep the y back to f and then g prime. Y's derivative becomes 1 dy dx. Product rule. Okay. Minus 2y squared. Derivative here is minus 4y. And then we attach dy dx. And then the 10 goes to 0. Okay, so now that's the hard step here because the majority of the points is earned trying to get to the derivative because all this stuff is going on. The rest is just trying to clean it up. So I see 3 dy dx terms. I'm just going to add and subtract so that I can get them all on the same side of the equation by themselves so that I can factor dy dx out. And once the dy dx can come out, then I just have to move all this over to the denominator, leave all that mess on the right side. That's your slope formula. Okay, number 5. Find the equation of the tangent line. So first thing to recognize is there's a need for product rule because x squared and 3 to the 5th root of x, these are both separate terms. And also to recognize that there's a rule necessary for this 3 raised to the 5th root of x. This is a to the u here. So the rule for 3 to the 5th root of x, we can think of this as 3 to the x to the 1/5. Right? Anytime I have a base constant raised to a variable, we use this rule a to the u. Okay, it's not e to the u, but it's a to the u. Still an exponential function, but it's not base e, so there's a little bit extra in front. So the derivative for 3 to the x to the 1/5, I'm just previewing this because we have to involve it in product rule, is natural log of a, natural log of 3, times the original function. And then this x to the 1/5 is power rule. So we do power rule here. 1/5 x to the negative 4/5. Okay, thank you. Okay, I'll take it. Thank you. So now that you see that there's a need for a to the u, let's jump into the derivative rule using product rule here. So f prime, x squared becomes 2x times g. Plus f, and then this whole mess is g prime. Okay, it's natural log of a times a to the u times u prime. All right, there's really no need to clean this up because we're just going to go ahead and find the slope, right? Equation of tangent line, we need the slope, so I'm just going to start inserting the x value of 1 into the derivative. This looks like a whole big mess, but the nice thing is that 1 is going to help cancel and reduce a lot of this mess. So 1 in for x, I get 2 times 1, 3 to the first power, which is 3. 1 squared is 1. Natural log of 3 stays. 3 to the first power is 3. 1/5 times 1 to the negative 4/5 is just going to be 1/5 times 1. And I'm going to clean up as much as I can. 2 times 3 is 6. Natural log of 3 times 3 over 5. Best I can do is just make it 3/5 natural log of 3. So that's my slope. I have my order pair, which is 1, 3. So now that I have my order pair and my slope, I can dump it into point slope form. Y minus 3 equals slope I gathered times x minus 1. Okay. Number 6. This is hint is to use log differentiation. The reason why we need log differentiation, because after we rewrite this, we see that this is a variable expression raised to a variable expression. And variable raised to a variable, we don't have a rule for. So the best way we can handle it is to get it into a different form. To get it to a different form, we take the natural log of both sides so that the exponent can be free to come down. So our next step after this is we say natural log of y is equal to natural log of take natural log of both sides, bring the exponent down in front. Now that we are in natural log world, we can bring that exponent down in front. And once that exponent comes down in front, now we can rely on other rules to help us get to the derivative. I'm going to rewrite this 1 over x as x to the -1 to get ready for my next step. I have to go through product rule. These are two separate terms. Okay, natural log of y, just implicit, 1 over y dy dx, right? Natural log of u is u prime over u. And then we go through product rule. F prime g plus f g prime, derivative, power rule, -1x to the -2. Keep the g function, back to the f, and then g prime here. Natural log of u becomes u prime over u, so -6x over 2 minus 3x squared. Okay, we basically have the derivative. The only last thing to do is to move the y over to the right side. We want that dy dx by itself. So once that y comes over, it'll be a little messy, but we're just going to want to replace that y back in terms of the original expression, or in terms of the original function. There's our derivative. Good. Okay, last problem here. This is derivative inverse at a point. First thing we do is understand that the 5 that you're staring at is not the x value, it's the y value of the original function. So we take that 5, set it equal to the original function, try to get to that x. It's a little bit of guess and check. I move the 5 over to the right side, and I'm just trying to figure out what x value will make this a true statement. Start with 0, then 1, then -1. Eventually, you're going to get to that number after a few tries. In this case, though, looks like 1 is going to be the best fit. So now that we have 1, we know that our order pair is not going to be 1. It's not going to be 5, 1. It's going to be 1, 5. So order pair is 1, 5. And once we know that, then things become a lot easier. We find the derivative, and then from the derivative, we can find the slope. And from the slope, we can flip that to get to the slope that we're really targeting. So f prime of x, power rule, 3x squared minus 6x plus 5. Put 1 into the derivative to find the slope, 3 minus 6 plus 5, which is 2. Once you have your slope, then take that slope and you flip it, and that's your answer. We're always just going to take the reciprocal. Don't change the signs. Just take the reciprocal, and that's the slope that we're trying to target. Okay.